Alright, another draft science video presentation. Doing the same thing over and over, but I'm trying to accommodate any counter argument, no matter how lame and silly. And so far, that's all there is, and that's all that we're going to get. I will double the wager, okay? So I'll give you 2-to-1 odds on the money, okay? So to do the experiment, I think it'd be very good to have the experiment done professionally, well done, so nobody can complain about the results. And the idea would be whoever's right pays for it, in a sense. So I'll give you 2-to-1 odds. So if I'm wrong, I not only end up paying for the experiment, but I got to pay you the money. And if you're wrong, all you got to do is pay the one amount. And that's it. Pay for the experiment, essentially. I don't get anything. I don't win anything. So I'm giving you such, here you are, you have billion-dollar physics, you got millions of people supporting your little religion, and yet you can't take me on. None of your brave soldiers can take me on. None of your courageous cats, conspiracy cats, none of your AB sciences, none of all these people are such flaming cowards that, they can't defeat me. And I'm going to pay them to do it, and they still won't do it? Come on. You got to smell this shit. But anyway, so the detractors can just continue. Okay, so he says, she explains where the energy went literally seconds after the clip you showed. So again, I've played the whole video 4 times. The whole segment on elastic and elastic collisions. I think you also need to learn the difference between momentum. So here they're doing the same crap again, like somehow we're supposed to learn a difference. They're both definitions of energy. There's zero doubt about that. I mean, even though Newton didn't call it energy, he called it energy, okay? I mean, every one of his laws is basically saying the same thing. This is energy in the universe. Velocity and mass is energy in the universe. They're two distinctly different answers to the same question. All right, so you can't keep playing their game like they're two. No, they're not the same thing. They're completely different things made out of completely different things. They're made out of exactly the same thing, mass and velocity. You can't keep playing this game. All right, vector magnitude with a direction. And the energy is something other than that? The energy doesn't have a vector. That is, it's not in a direction. It doesn't have a magnitude, and it doesn't have a direction. I mean, vector and direction is sort of redundant, but regardless, how is energy any different? The energy in the car doesn't mean it has 100 joules in every direction. If I'm going 60 miles an hour down the road in my car, and you say that my car has a certain energy, you're saying it's not because, the back of the car has that energy. The top of the car doesn't have the energy. Even the wheels on the road don't have that energy. Clearly, the description of the energy is the energy if you're standing right in front of my car. I mean, this is so frickin' lame. Anyway, and kinetic energy scalar only magnitude. So clearly it's not only magnitude. It would be ridiculous to say so that the energy is going in every direction. That's just absolute nonsense. So I replied. I played the video 4 times on this channel. The rest of the clip just proves my point. Yes, I wish I had played it in the video because it just clearly illustrates how clueless this biatch is. She says half the energy was lost to heat and deformation. So clearly, if I'm going down the highway in my car and I decide to run over Pyro, I have to sacrifice something to do that. I can't keep my momentum and kill Pyro, right? Can't happen. I can't make a whole bunch of sounds. I can't open and close my doors and block wind. I can't, my wheels can't be all squeaky because that indicates friction. I can't make any sounds. I can't make any vibrations. I can't affect the environment and say I'm going to keep all my momentum. You can't do that. Clearly, the premise of the entire argument is that this transfer was complete and there was no degrade in the total momentum. You can't have no degrade in the momentum and then claim I made noises, I ran over Piero, I did all this, I toasted bread, I heated New York, I did all these fantastic things with my little bit of motion. You can't keep the value of the motion, which is momentum, and then say, I used a lot of my motion to run over things. It's insipidly stupid. I say for the 400th time. All right, and I say again, how can you 100% transfer the momentum and then claim you lost half the energy that created that momentum? You only have the momentum because you had energy. Energy gave you a velocity. You don't have an engine. You don't have squirrels pushing you. All you have is your motion, your momentum. And if you have to do anything with it to make a noise or to make something vibrate, then you have to lose some of it. I mean, how can you completely transfer the energy and then say you spilled half the energy? You are asserting things dumber than a flat earther. I mean, it really is dumber. As I stated, any losses to heat, vibration, sound must reduce the velocity portion of the final momentum. The final momentum can't be, I saved it all, and then you say, but I used a bunch of it to kill people. Can't do both. It's like a bullet example, right? I mean, I can't, if I shoot one person with the bullet, the bullet's not going as fast the second time. Right? The magic bullet in the whole Kennedy assassination. The bullet went into Kennedy with a certain momentum. By the time it got to Connolly's arm, his wrist and his leg, it was going pretty damn slow. I mean, these people are just so dumb. Oh, so yes, let's just play the videos. Okay, so let's play the retarded, stupid, moronic. This isn't the right thing. What the hell happened? I had it. I had it set up. I had it ready to go. It was right here. It was ready to go. Who stole it? Somebody stole it on me. All right. Well, maybe I'll pause and go find it again, but it was right here. That's not it. Amendum isn't it? All right. Well, I'll pause and I'll go find it again. All right. I like this pausing thing. It's very convenient. I have to remember to keep using it. All right, so this is where we left off. So she pointed out 100% of the momentum was transferred. So you couldn't kill Piero, you couldn't smush a bird, you couldn't vibrate wheels, you couldn't run over a frog, you couldn't hit a grain of sand, you couldn't fly any sparks off, you couldn't do any of that stuff and maintain the 6 miles an hour, which meant your momentum was conserved. So you couldn't have had that speed final if you hit anything or you used any of your momentum. All right, you can't use it and keep it. Not possible. So now she explains how, look, the joules don't, look at that, we lost half the energy. And now she's going to explain where the energy went. And this is where my brain explodes again.
We lost kinetic energy. So what happened to the energy? Well, in an inelastic collision, when the...
So we're going to just play a game. In an inelastic collision where we conserved 100% of the momentum, we can do a whole bunch of other stuff with that momentum too. We can use it 3 or 4 times. We don't have to use it just once. We can actually use it exactly twice. That is, we can use it twice.
The colliding objects stick, some of the original kinetic energy is lost.
Right, so we know in a real experiment it would be lost, and that would mean you wouldn't leave at 6 miles an hour, right? You start at 12, you're going half, splitting the mass and proportionally, you're just reversing the mass with the velocity. So you went from 12 to 6. If you made any noises, then you're 5.9. If you run over Piero, Piero doesn't have much in his head, so that's like an airhead, but he's also a fathead. There's a lot of fat. So you're hitting a lot of fat. So that's really going to steal from your momentum. I'm just saying there's no way you can do any of this crap, this losses to the environment, and claim it was going 6 miles an hour. It couldn't have been going 6 miles an hour if you made any sounds or you deformed anything. Then you have to be going much slower, which means your 72 number has to go down, 65 or 58 or 42. So now your difference is even bigger to point out where all this energy went. And again, just think of how the amount of energy this is. Let's say it really was a 5-ton train, right? 5 tons. And then you bang it into 5 more tons. And now you have 10 tons, moving at 6 miles an hour. 10 tons moving at 6 miles an hour. And she says half of that energy went somewhere. You can imagine that's a hell of a lot. That's like 10,000 megawatts. I mean, that's a lot of energy. She said, we just lost it. It's gone. I don't know. Slipped away. And again, even if we conceded her point and we did the experiment real and we found out it wasn't 6, it was 5, well, then the problem is she has even more to make up. She has to make even up a bigger difference. You've lost even more than half then. You've lost 60% of the energy. It's even harder to explain. Oh, this is so bad. I just can't believe you fanatics are this. You're just this glued to. Again, I showed you the history. This is a silly formula invented under silly circumstances. It has nothing to do with science. Why are you clinging to this?
Some of it escapes as heat. Oftentimes it goes into the object's mechanical deformation, like if you throw an egg.
So, did you describe any of that? And we know that egg right now just lost a hell of a lot of momentum. Yeah. So it can't do all of that stuff and then transfer all the energy to the apple. The apple can't leave with all the energy if all of that crap happens. A bunch of crap explodes and goes in all kinds of directions. The momentum's got to go in those directions. That's where the fuel is. The fuel has to go with it. Anything that leaves has to be fueled with your fuel. All you have is your momentum. There are no other sources of energy. If you 100% transfer your momentum, it means you gave all of the energy from the battery. There's nothing else for the battery to make happen. All of the battery's energy was moved. You can't make the battery light LEDs and do other stuff. It can't. Because it doesn't exist. There's no energy for your deformation to happen.
Against the wall and it deforms, or a ping pong ball hits some fruit and it deforms, the energy isn't lost to the universe, but it...
Yes, so again, just realize what you're saying. Half the energy of the 10-ton train going 6 miles an hour, half of its energy gone. So it's half means she's basically saying another train going 6 miles an hour and weighing 10 tons. A whole 10-ton train going 6 miles an hour, all of that energy disappeared. That much energy disappeared. See, we have a joule number for the 10-ton train. The 10-ton train is 72. The 10-ton train going 6 miles an hour, let's say the number 72. We know it's 72,000. But regardless, 72. Right? And we know the other number is 144. We know it's twice as much. So the fast train going in had twice as much energy, and we lost an entire 10-ton train going 6 miles an hour worth of energy. Now, do you think anywhere that ever happens in the real world? I mean, nothing's that inefficient. The space shuttle isn't that inefficient. Nothing is that inefficient. That's an preposterously insane inefficiency of a collision. I lost half the energy. That's terribly inefficient.
It is no longer in the system of the two things that collided, so we can't easily measure it.
All right. Isn't that a cop-out? You can't measure it because it doesn't exist as lost energy, because if it was lost energy, you would have lost the momentum. So this is so dumb. She's so pretentious. You're all so pretentious. You all think you're so smart. And here you are praying to a frickin' plastic totem pole. I mean, this isn't even a real one carved out of wood. It's like molded out of resin. It says 1998 on it, China, made in China. I mean, you're such dupes. You're so frickin' silly. And here you are ridiculing me? Like I'm an asshole? Oh, I mean, come on. Douchebag, heal thyself. Pretentious douchebag, heal thyself. These people. All right. So, one down. PBS. PSB. You said there are tons of examples that this isn't true. Yes, so the train example, the plain obvious thing where you drop an extra weight on, yeah, there's lots of those experiments. So I can show you that it loses half the energy. I mean, it loses half the velocity. You double its weight, the momentum is the same, but now you've changed the proportions. The 10 mass thing is now moving at half the velocity. You conserve the momentum. The videos are titled Momentum Conservation. So there's just no doubt about it. Show them to me. Okay, I'll do that. Show me an experiment where it says that you say about the spring. Well, the spring experiment is the very one I want to do because I can't find it. Now, I've said before, I'll pay a bounty. If somebody can find the experiment where they just take a spring, compress it, then they put a light weight on it and shoot it, and then they put a twice as heavy weight on it and shoot it. Same spring compression. I mean, this is so simple. You're saying it's got to be somewhere, right? Right? And you just measure the fact that it's exactly the same energy in both objects. You don't measure how far they go in space because we know the lighter thing goes higher. We're talking about how much it compresses a spring. So we know when it goes higher, it's going to come back down and compress the spring exactly the same amount. So it's the same momentum. The momentums aren't different. Yeah, there's no other way to say this. Yeah, there's no other way to say it. It doesn't matter how big a thing I put on it. So the real experiment will be this one. Okay, so it's really this simple. But apparently, I mean, every physicist I think knows the answer to this. So this guy's obviously not a physicist. Because every physicist knows how this is going to turn out. I mean, there's not going to be any doubt about it. So I take a spring and compress it a standard amount. And then I just shoot an object into another spring. Okay, all right. So first I put a 1 mass unit in. Okay, and I compress the spring this much for everything. Everything I'm going to test, I compress it exactly the same amount. So I put a 1 masser on it, and then I shoot it, and it's going to compress the catching spring a certain amount. So we'll just call this a 5. So 1 mass compresses it 5. Then I just replace this with a 2 mass. Now we know, logical people know, the 2 mass is going to go slower because it's heavier. But it's got the same exact momentum because the same force is pushing it. Okay, so it's got twice the mass and half the velocity. So it's just the same inversion, same momentum. It's going to hit this spring and it's going to be a 5 again. Same force here will result in same force here. Okay, so maybe there'll be a little loss to rolling, so we'll just say, 4.999. Okay, so it's every time it's going to be 4.999. I'm going to put a 5 compression here, and I'm going to get a 4.999 compression there. Same springs, same compression ratio, same spring constants. And so he thinks that when I put a lighter thing on, he thinks when I put the heavier thing on, it goes more than half the speed. So instead of the speed being 1/2, the speed is going to be 3/4. Because then the kinetic energy formula is correct. Because then the kinetic energy formula works. But it doesn't work unless I make the momentum increase. So he doesn't fix the problem, right? The obvious paradox is that the same thing can't have both of these definitions. So as I was saying, they're basically saying that all I have to do is put light things on springs and I make more joules of energy. So I want to increase how many joules I get out of a system, just put light things on and I get more joules. His system is just saying the opposite. If I want more momentum, just put heavier things on the spring and I get much more momentum. Okay, but that's what it means. You can't make these two things compatible. There's no compatibility. They do not equal. They are not proportional. They are not in any way compatible. But anyway, so that's the simple experiment. Okay, right? I mean, that'll settle the issue, right, for you people? That just solves it right there. We're all done. We don't have to fight this anymore. I'm saying no matter what size weight I put on here, I'm always going to get the same compression here. Same compression here will lead to same compression here. And your energy formula, because the velocities will keep changing all over the place, your energy formula is going to keep getting wrong answers. It's going to say one object has 350 joules, and the next object's going to have 770 joules, and the next object's going to have 1,468,000 joules, just because I made it lighter. But the joules will never show up here. What will show up here is always going to be a 5. A 5, a 5, a 5, a 5. So if it's a bullet or a bowling ball, I'm always going to get a 5 here. Just doesn't matter. I think most physicists know that has to be true. I don't know how they could even function in physics if they didn't know that logical bit. That you can't create energy by putting lighter things on springs. And you can't create more momentum by putting heavier things on springs. That's not possible. Alright, let's see what else he said. Show me the experiment where it says what you say about the spring and the two masses and the momentum will be the same. I will wait. Well, as I said, again, the whole point of me having this contest was to do the experiment with the springs. Now, I wish there were spring experiments. Now, I think I could show you one where springs and they shoot them straight up into gravity. But obviously, every idiot knows light things go faster into gravity. The faster you go into the gravity, the further you'll go into the gravity. So speed, it's a huge prejudice for speed, not for momentum. It doesn't, the height it goes isn't showing you its momentum. It's showing its velocity. And its momentum is mass times velocity. So we know the heavy things don't go up as fast. And we know the light things go up really fast. So, you know, I could show that experiment. I could show they keep landing on the spring with the same amount. You know, they come back down on the spring and it goes down just as far as what it started at, and then it shoots back up again and comes down the same amount. So I can put a light thing on one side and put a heavy thing on the other side, and they're both going to land with the same energy. Even though this one went 4 times higher, it's going to land with exactly the same momentum that it was left with. I mean, the pendulums prove this. But anyway, all right, so that's the response to that. Well, I will wait. Let's see. I want the experiment with the spring and the two masses. I want the same thing from you. Just show me the experiment where the momentum increases. So I use the same spring, compress it. I put a light thing on it. I get less momentum than when I put a big heavy thing on it. Then I get a lot more momentum. Show me that. Do you have it or are you lying? Or do you have it or are you lying? Can you show me the experiment? You know, not somebody just saying it. Not somebody calculating it. Show me the experiment doing it. I mean, it's only a spring. You should be able to come up with a spring experiment showing me how momentum increases when you put heavier things on a spring. All right. All right. I want the experiment with the spring and the two masses. Do you have it or are you lying? So again, I'm not lying. Again, no use of Newton's second law. So again, it's Newton's second law doesn't say much, does it? I mean, realistically, it almost says the same thing as momentum equals mass times velocity. And the only thing it's changed is it's saying F for momentum. It's the same different force, energy, doesn't matter. You could use either one of those words will work. And what does it equal? It equals your mass times, and in the case of acceleration, your change in velocity. Well, what's the difference? Isn't my change in velocity a velocity? If I go from 3 miles an hour to 6 miles an hour, what's my change in velocity? Oh, 3 miles an hour. So I'm just multiplying a velocity times the mass. And that tells me the force. So isn't it really just the same equation? Isn't it just saying E equals mv? Yeah, it is. All right. Again, no use of Newton's second law, so still you don't understand it. So, no, you don't understand it. You haven't shown me anything called a rational derivative. Somehow you think because you're calculating the initial velocity minus, okay, and it is a minus, your final velocity, you think you don't minus those. You just multiply them. Yeah, you know, you don't multiply v times v. You subtract initial velocity from final velocity. That's what you're supposed to be doing to figure out acceleration, moron. All right, understand how difficult it is for you to use this simple law. So again, it's the law has nothing, is never saying what you're saying. Clearly, Newton never said any of this stuff. Newton had died before this had become a big controversy, so we don't have Newton's insight on it. But clearly, this was the attack against Newton. The existence of 1/2 mv squared was clearly for no other purpose than to attack Newton and Descartes. Are you saying that Newton was not consistent with Descartes' mechanics on this subject? This is just so bad. And solve a simple example. So again, solve, 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 solve. Prove, 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 prove. I like proofing a lot better than people solving, okay? Solvers I don't trust. Provers I like. People who do the experiment and show it. You're not showing anything. You haven't linked me to a single video demonstrating your bizarre notion that the same spring creates different momentums. All right. Fingers. Oh, that's a Ken Wheeler commenter. Oh, forget it. All right, my answer is that's Puro. Okay, so moving on to Jerry. Okay, that'll be it for this fun-filled adventure. Well, let me show the other video. Yeah, I'll do that. I mean, just again, it was one I already showed before, but I just remember. I said, well, wait a minute, why don't we just go back to that nutty video? All right, so let's play this a little bit. I mean, it's Newton's third law, but it's really Newton's second law. But anyway.
One and the same force acts on both.
Okay, so one and the same force acts on both. So it's just like, pushing them both into a spring is the same as tying them to a spring and separating them. I mean, we're talking about the generation of a force. And the force is equal on both of them. It doesn't mean it's a constant force pushing on them, and how long they're in the force is how much energy they collect. No, it just means that they both are having the same force put in them, essentially. It's being pushed right into them. At the same instant, they're both being given the same amount of force. Gravity's doing something completely different. Gravity is applying the force based on how much mass you have. This force doesn't care. 50% for the light car, 50% for the heavy car. They're both going to be given the same momentum. Okay, so I don't know how you could understand it any other way. They're both going to be given the same amount of energy. The light car will be able to go faster with its energy than the heavy car, obviously. But they will both contain exactly the same amount of energy. So unlike gravity, where you have to collect the energy based on how much mass you have, so the longer you're in the gravity, the more you collect. No, very different.
We witness an astonishing thing. Here is the massive car. Here is the little car, less inertia.
Right, so they're half, actually. The heavy car is twice as heavy as the lighter car.
There is the spring. Now, what did we see? The same force acted on both. But you notice that the smaller one had the bigger acceleration, and the bigger one had the lesser acceleration, and therefore...
Yes, and the acceleration led to a velocity, and the velocities are inverse to the masses.
In the same time of travel, and they would both travel the same time.
Right, but one of them traveled more distance. So Puro would somehow think it had more energy because it traveled more distance. No, it doesn't have any more energy because it's twice as unmassive. It's unmassive. If you don't, the mass is proportional to the force. I mean, another way of rewriting F equals ma is mass is proportional to force and acceleration is proportional to force. Because the two are just multiplied times each other. One of them isn't squared. There is no bullshit in there. So the point is they're both partners in creating the effect. So if you lower the mass, you can increase the rate of acceleration. And if you increase the mass, you have to lower the rate of acceleration.
From time zero to the time of collision, clearly the smaller one has the higher velocity. So, writing the momentum of both cars, we would equate it as follows. The large car has a little velocity, the little car an enormous velocity, and these momenta are equal.
All right. So, look, the guy says physics is his business, okay? Now, you can say he's wrong, and you should leave a comment saying he's wrong. Okay? So then we don't have to have this argument. So he's clearly saying both objects are collecting the same energy from the rubber bands. They both get the same energy from the bands. And one of them, the lighter car, can obviously turn that energy into more velocity, where the heavier car can't, because it has too much mass to spread it over. So it can't get as much velocity. And he's clearly saying, though, in energy they're equal. In momentum, they have acquired the same momentum from the experience. So one of them doesn't have, whatever, the little car is going 10 and the other car is going 8. Okay? It's a 50-50 partnership. I don't know how it's this, been over it so many times. It's just... Alright, so this is dumb old Jerry. Imagine two objects with same momentum moving towards each other. One has momentum of 5 and the other has minus 5. So again, this nonsense that somehow this energy thing isn't the same exact thing as the momentum thing. There has to be a vector that they have not in common, in the opposite direction, right? Two things going like this can hit each other. Lots of ways to hit each other, but you can't hit each other if you're going like this, and you can't hit each other if you're going that way. You can't hit each other lots of ways. So all these plus and minus signs don't mean a damn thing. Momentum is always positive. You never have negative momentum. It's just a baby talk to say this one's positive, and I'm just going to arbitrarily say this one's negative. That's crap. They're both positive values, and all you're really looking for is whether or not they are in opposite directions. And the same is true for energy, and it's just a sick, disgusting, putrid semantics baby game you're playing to pretend the energy doesn't have a vector. Yeah, it does. All right. In a perfect inelastic collision, the total momentum will be 0. No, it really won't. Okay, because both objects are going to be totally deformed. So you're going to know, hey, something really happened, because it's not going to work. You're not going to be able to swing two things into each other. So they have to be inelastic in the sense if they're elastic, they're going to bounce off of each other, and you're going to see that. You're going to watch it actually happen. You're going to watch this one's motion go into that one, and this one's motion go into that one. You're going to see that happen. And so when they're inelastic, what it means is, I'm just going to see them completely deform. So it's not going to be 0. I'm going to see that it's not 0. It's just the way they're going to misshape. And they're going to probably twist around each other. That the real event is going to be that they're going to never be able to hit perfectly equally, and they're going to start turning and deforming in that shape. So this is just more baby talk. Okay. That's what we get when we add the momentum in line with the law of conservation. So again, there's this law of conservation. You're talking about a law not of conservation. You're talking about two laws, the law of exchange. And you're just saying, look, we call it conservation sometimes when one force moves right into another package. But clearly, it can move into other packages. So if there's atmosphere and there's this and that, I can transfer the energy to some other location. There's still transfers, and in no way do I need this moronic lesson that those transfers have to come out of your momentum. You're the idiots trying to defend some notion that I can conserve the momentum. That is, I can transfer 100% of motion and still lose energy. You're the idiots that need a lesson. It may seem strange. No, you're the retard. Okay, that something is 0 and conserved at the same time. Again, you're the one saying energy can be lost or momentum can be lost. I'm not saying either one of those can ever be anything but conserved, except in the case of gravity, of course. But, so why do I need you to give me this horse shit? I'm not the one claiming loss of energy. You are. It's your team that's saying, we lost half the energy. You're the one saying that without explaining where the hell it went. Where the 10-ton train going 6 miles an hour where it just disappeared to. That much energy. Just never saw it. Well, I don't know where it went. You're the ones who don't understand the concept of conservation. All right, may it seem strange. Important to remember. Oh, fuck you. That speed depends on your reference frame. So again, this has nothing to do with reference frames. We don't really care who actually has the velocity, right? We're watching a bullet hit a head and smash the brains all to pieces, right? Do we really care whether the brain was moving 10,000 miles an hour and the bullet was just standing there minding its own business? No. Who cares about your little semantics games you want to play with, your little relativity bullshit? We're saying for the sake of argument, the only frame that matters are the frames not going in the same direction. So whatever the bullet and the head don't share, whatever motion they don't share, that is, they're not doing together, that's the only motion we care about. And we really don't care whether the whole universe moved the brain into the head, into the bullet. We kind of know the bullet actually went into the head. And so why are you playing this game that technically it might not have been that way? The whole universe might have pushed Kennedy's brain into Oswald's bullet. Oh, yeah, maybe that happened. What do you think the odds are, moron? Gazillion, bazillion to 1? The bullet didn't really have the velocity? Fuck you. Oh, God. I mean, if this says to make you hateable, how obviously hateable do you have to be before I have a legitimate reason to hate you? It really, in reality, speed is relative and things are always moving. La 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 la. Doesn't matter for any of these experiments because we know we're just comparing two explicit motions in opposite directions. So that horse shit doesn't have anything to do with this conversation. You goddamn know it. You're just evading the subject again. There is always momentum even when it's zero. La 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 la. There's not always momentum, so that's again a lie, even when it's zero. There can be something. You're basically saying nothing in the universe is just in one place and isn't really going anywhere. It's not possible. Yeah, it is possible, asshole. All right, it's zero from one perspective. Yeah, fuck you. Another way to put it is that momentum depends on where you are when you do the calculation. I mean, this is such weaselly crap. I mean, it's an overt, disgusting paradox. You're saying you can get more energy by just putting lighter things in front of explosions. And we can make more joules of energy. Oh, fuck. The cart that hits the spring and compresses it will give it a potential energy of 125 joules. So again, more horseshit about a potential energy. It's clearly kinetic energy. When you replace it with the other cart, gave the spring a potential of 125. Yes, that's correct. Okay. When you replace it with the lighter car. So he's talking about, we've taken the light car and we've transferred it into a heavy car. So now we have 10 tons going 5 miles an hour. We're going to compress another spring, take that compression and put the 5-ton car in front of it, and we should get back our big number of joules again, back to 250. All right. When you replace it with the other car and release it, the spring, it will reach a speed of 7.7. So he has a comma, but whatever. So that's exactly what I said the other guy's saying. Now, they're only doing that because they're calculating their formula and saying that's what my formula says. So I just showed you, this guy. He didn't say that. He would have pointed it out if it's not an inverse relationship. He would have pointed out that, it works out that the momentum changes. See, he has an equal sign there. Do you see the fucking equal sign? Do you see it? I mean, right over there. You see the fucking equal sign he has there? So you can't say it's 7 for the heavy thing and it's 10 for the light thing. Can't do that because you're not going to end up with the same momentum. You're not going to end up with your kinetic energy formula is going to break down, because now you're not going to get the right kinetic energy number. If you 5 times 10 is 50. 7 times 10 is 70. Yeah, that's all I should have to say. All right. It's not the same momentum. You just said momentum is the same. So you can't say it's not the same. That the heavier thing will end up going 7 miles an hour. No, the heavy thing has to go 5 miles an hour. The thing weighing 10 has to go 5 because the thing weighing 5 went 10. Has to equal. All right. I've already made that point, but just saying. Which means it'll have the same kinetic energy as the first one. So again, he's just making it now, so I just put heavier things on the spring and I make more momentum. So when they kept the other argument, they were saying I put lighter things on the spring, I make more kinetic energy. When I put heavier things on, I make more momentum. So they're just broken momentum. So momentum is no longer an equality. It's no longer inversely proportional. It's completely broken, so they can save their kinetic energy formula. So the only way they can make their formula make sense is they have to break momentum entirely and pretend that the same spring can produce different momentums. All right. Conservation of momentum is tricky. Well, apparently I don't think it is at all tricky. I think these little spring experiments will show how simple it is. I guess when the spring is hit, some of the momentum goes into whatever the spring is attached to. So here's, what's the point? Yeah, obviously, that's the whole point of the equal and opposite reaction, okay? Because the action is really pressure, and it pushes both ways. So yeah, half the energy always goes into the other object. In this case, it makes more sense to focus on the principle that what goes in goes out. So you just stated not what goes in doesn't go out. You just stated if the cart has 7.7 meters per second velocity, I got more momentum out of the spring. The same spring gave me more momentum when I put a heavy thing on it. Oh, it's just too stupid. All right, the second cart won't have a momentum of 50 like the first one because it's not stored in the spring. So again, it's the same exact spring. You can't play this bullshit game. You can't do this. All right, anyway, you're breaking the law, okay? And you're certainly disagreeing with physics girl, but she clearly pointed out that the light car, the 5-ton 10-mile-an-hour car became a 10-ton 5-mile-an-hour car, not a 7-mile-an-hour car. And so if I'm compressing the spring with a 5-mile-an-hour car, you can't make this argument that I really compressed it with a 7-mile-an-hour car. And clearly the momentum wouldn't be conserved because somehow it gained a momentum. If the 10-ton car is now going 7 miles an hour, it means when I hit this car into the other car, I made more momentum. How can I make momentum by crashing into a car not moving? How can that make more momentum? I hit with 50 and I get 70 out. You don't think that's free energy? I mean, they just, what's the point? Like I said, you can't communicate with humans. In this case, it makes more sense to focus on the principle. Well, okay, we already did that. The second cart won't have the momentum of 50 like the first one because it's not stored in the spring. So just amazing. Conservation is only about objects that are involved in a collision and isolated. So that's more nonsense, right? Because we know that you're using the word conservation to mean the environment and everything else. But I could be wrong, of course. Then why are you doing this? Why are you getting into this conversation? If you're not quite confident, please don't do this nonsense. But you're really wasting everybody's time then. Really. That's how we got into this mess. There's a bunch of people in the 1700s doing wishy-washy. Well, it seems like, that experiment looks like it, but that one doesn't look like it. I don't know. Whatever. Can't we just flip a coin? I mean, Fuck this wishy-washy bullshit. The whole point of science is to get right answers, not wishy-washy answers. Oh, let's just have a duality. Momentum, kinetic energy duality. Dualities are fun. Photons are waves. Oh, but when we want them to be, they're particles. You don't see how this is just disgusting physics? Ugh. God, I hate you. Yeah. I don't know whose head is full of more fat, yours or Pierrot's. Well, you're certainly not as obnoxious as Pierrot, but yeah, I don't know. That's a tough physics question. Who's dumber? Dumb or dumber? Yeah. Anyway. Alright, so I guess that's it. Yeah, that's all I need to do. I'm tired of this shit. It's got to be a way to, I just don't know what the way is, right? Because I know if I prove it, they're just going to start saying some other horseshit, right? I mean, if I prove the spring always creates the same momentum, I can't make the spring shoot something at the wrong momentum unless I make the object so light, that the spring can't push it at the fast enough velocity. The spring doesn't move fast enough to give it the velocity it wants to. Because it can't. You can't go fast enough to impart the velocity because the object is lighter than the spring. But other than that, you're going to get all of the momentum from the spring. No matter how big a fat ass I put in front of that spring, the spring is always going to give it the same amount of energy. It only has that much to give, and that's how much it'll give. So, well, whatever. Like I said, so I have no example of momentum failing to work. So every single mechanical circumstance you could show, I'm arguing that momentum, if you just follow the momentum, you'll always get the right answer. Always, always, always. Now, they'll never show me one experiment. Just show me one experiment. One experiment where momentum, following the momentum, doesn't work. And they won't do that. And they won't, I can't pay them to show me to be wrong. So even if I offer them $2,000 to show me to be wrong, they won't take the money. I mean, what else can I do? I'm giving you 2-to-1 odds in a contest to, I'm clearly attacking your nonsense physics, okay? The physics all of you believe, the Sean Carrolls, all those people all believe it. I'm giving you 2-to-1 odds, even though I'm the incredible underdog, the one man against the whole billions, right? And you're still not going to put your money down? You still can't pony up some money? Amazing. Alright, so that's all. Yeah, fuck it. So, till, again, the next time, when who knows what I'll do, because, I'm just wasting so much time on this one subject, but, it's so obvious. If you can't get this, how can you get any? No wonder the other arguments haven't been very effective, is because you're completely resolved to be belligerently stupid. You're just going to remain ignorant and wrong, and you just couldn't care less about the truth. You're violating, you're raping. You're sitting here raping it right here in front of everybody. And you're so confident no one will pay any attention because we're all rapists. And I just didn't know that, I'm on the planet of the truth rapers. I didn't realize. That's all there are here is truth rapers. Shit. My misfortune. Anyway, till the next time and such, and so forth and whatnot.